Hey, hello, welcome to the show. It's me, John Park. It's time for JP's product pick of the week. I'm back. Thank you so much for your patience with me being gone last week, but now I'm here. I'm here and I'm ready to do this. Are you ready to do this? Let's do this together. What is happening here today? I've got a product pick for you, a new product pick. Pretty brand spanking shiny new, I think. And what's happening? I'm gonna tell you where to go to check it out. This show, in fact, is broadcast from inside of that product page. You can go to that QR code. You can go to that URL. You will find that the product team has taken a stash of them, 100 of them, in fact, put them away safely before the show, and then released them. So now they're available to you at half price, slashed in half. You don't have to do anything with coupon codes or anything. We've just cut the price in half. You can go there now. You can go check it out. Or if you like the mystery of it, you can wait for the reveal. It is, as it is customary, what I like to do is have Lady Ada tell you about it in her new segment, and then I'll give you a bit of a live demo here, and then you can decide if you want one or some for yourself. So before I go any further, take it away, Lady Ada.
Here it is. What is this?
This is the CC Fixer, a product we wish we didn't have to make.
The Fixer.
But we actually needed this in-house because I needed it for a couple products that I purchased that don't have the USB CC pins. And so when you try to charge them from a USB power delivery plug or from a computer like a Mac especially, direct from a USB-C port, they won't power or charge or sync because they're not providing the 5 volts. And that's because the people who designed the board forgot to put the two 5.1K resistors on there. And this kind of drives me nuts because it works on some computers, not others. It's like inconsistent. Like I always use a to C converter cable, so I don't notice, but then I give it to you and you're using a MacBook, it doesn't function anymore. So what this board does, and I'm showing it with a little like USB PD analyzer, is it will signal, I want 5 volts up to 3 amps. There's a little green LED to let you know, and it just fits on the end of the cable or connector. It just goes in the middle, and it will just trick it into always providing 5 volts. So you don't have to think about it. You don't have to worry about it. So have one of these around, and then, we just added to the charging cable for the devices that we need to charge.
Trick it real good. Put this on or in your special cable box, because when you're going through your cable, trying to figure out, is it the cable, is it the device, whatever, have one of these, figure it out. We have a baby monitor.
Yeah, because it'll fix it. I have a bunch of devices, low-cost electronics that they screwed this up.
Yeah, and let me just, before we just get off this here, so we don't want to have our baby stuff on the internet, so we have one that's not on the internet, but it transmits, and unfortunately I have to always remember that it doesn't like other USB cables that are more common, so I have to have a special one.
Yeah.
And now I have this and I can use it for anyone, and it's very handy.
Yeah, and you can use this for sync or charging. Like it has the D plus and D minus lines come through.
Okay, and they want to know, is the data line connected?
Yes, the data lines are connected, but the CC lines are they're pulled out.
They're under our control.
They're done up right. So you get, it's for 5 volt USB 2.0. Obviously, if you're using something that uses the sideband pins or the high speed TX pins, you're not going to have this issue, because if they are using those, they did it properly. This is for those like low cost things that have USB-C ports.
Yes, that's right. This is my product pick of the week this week. It is the USB-C CC Resistor Fixer. It's the Fixer. What is this? Well, if you're using a C to C cable, in fact, I'll show you what I'm talking about right here. Here is a Apple branded, nice, fancy, expensive cable. And it should, by all means, be able to tell the power delivery wall wart or device to grab 5 volts for your gizmo. You should just be able to plug this in. However, on a lot of lower end or misdesigned devices, it's just not going to work. You won't get the 5 volts over this. You'll plug in a nice power supply, a really nice cable. It's USB-C on both sides. You plug it in and nothing happens. I had this happen to me on a bunch of different devices, in fact, trying to charge things, even USB-C ports on a battery. I'll show you a little demo of that. I've got a nice little battery here. I plugged it into a power delivery supply and I was like, what's going on here? This is all good, high quality stuff. Why isn't it working? Well, it's because of 2 missing resistors. So what this has, let me go to the product page here so you can check it out. This has a pair of 5.1K CC resistors that tell the power delivery supply, hey, I want 5 volts, give me the 5 volts, without those on the gizmo. So here's another one. I'll show you a live demo of this one. This is a nice little handheld gaming machine. They forgot to put those on there. You plug it into a normal USB A to C cable, no problem. You'll see right here on the bottom, that's a USB-C plug there. But if you get slightly fancy and you go C to C, you may just not see anything happen, and the thing will sit there. In fact, the first time I did this, I didn't pay attention. I just plugged it in, assumed it was charging. It was not. I was sad the next day. So this right here, if you take a look at the close-up photos there, you can see it has a USB-C port and a USB-C plug. So this is just a little fixer that sits in the middle. So you go cable to this to gizmo. 2 little resistors on here say to the CC lines, hey, I want 5 volts, please. And it will get the 5 volts, send that along over power and ground. This also has, this is a question that comes up, the D- and D+, the data lines, so you can pass through your data. I'll show you a little example of that in action as well. And you will be able to power your devices, and in a case of going, let's say, a MacBook with USB-C to USB-C, you'll be able to get power on it, and you'll be able to code the thing if it's a microcontroller or something that has a firmware update required, that sort of thing. So let's do a little demo. I'm going to jump to this little down camera here. So I think this is a nice example here. I've got my little Miu Mini Plus. It is a Linux-based handheld gaming machine, lovely little device. And you can see here I've got a bunch of different systems I can emulate and play games on. Up at the top there, this has a LiPo battery in it, and it says we're at 51%. So if I take this cable, this very cable, which, let me unplug for a second and show you what I'm running it from. I happen to be running it from a very nice Apple power supply from my old MacBook Pro. That's a power delivery charge or power supply, so it should be able to give 5, 9, 12, 18, 20 maybe volts, depending on what's asked for. However, as you'll notice, looking up at the top here, it says 51% full. I've got a little battery gauge there. It's yellow. I'll go ahead and plug in my cable. It didn't ask for anything. This has not moved to any sort of a charging symbol. So I have this really nice expensive supply and expensive cable and neat gizmo and no charging going on. So sometimes you can just fix this with a USB-A cable, but now you're talking about having a separate power supply. Very annoying. So instead, if I take my little CC fixer and plug that into the cable, you can see, first of all, if this lights up green, that means that, yes, we are successfully negotiating the 5 volts from the supply. And now when I plug this into my handheld, you can see it has switched to a charging symbol. Yay! Here's another example of this. So I'll go ahead and unplug that. We won't play any games today. Here is a neat little USB power meter. We sell these in the Adafruit store. This should tell me the voltage and current draw. Nothing. It didn't power on. Why? This thing forgot to include the 2 resistors necessary to ask for 5 volts, so it's not getting 5 volts. I'll go ahead and put the CC fixer in the middle there, plug this in, and hey, look, it has lit up. It's asking for 5 volts. Now, I'm not powering anything with it right now, so it's going to just stay there at 0 amps of current. But if I plug that back into the handheld here, you'll see now it's asking for about almost 2 amps there. So it's going to be a nice fast charge. So last one I'll demo for you. Here is the little battery. I love these little battery packs. This one can supply over A and C. It can be charged with C or charged with B. So again, I'm trying to live a USB-C lifestyle here. I'll go ahead and plug this in. No LEDs, nothing. It's not charging. All right, so let's plug in our USB-C CC fixer. Plug this in. Et voila, we have some lights there indicating that we are charging. So yay, that's good news. So that is what it does. It's straightforward, it's simple. You could potentially, if you knew you were going to be using this mostly for charging, put a little heat shrink over this, or maybe make a little 3D printed gizmo that kind of clips these together. But I think get a couple of them, have them in your backpack, have one in a drawer somewhere. You'll always be able to grab that and put it to good use. One other thing I'll demonstrate here, and I'm going to use a different cable just because I don't actually have a USB-C port available on this computer that I'm using here. But I will take, this is an A to C cable, so this should just work anyway. However, pretend for a moment that this is USB-C to USB-C. I'm plugging into my computer. I want to be able to power my device, in this case a little Adafruit Metro RP2040, and I want to be sure that I still have the ability to send and receive data, because I want to code the thing. So you can see I've plugged it in, it's powered up, everything is hunky-dory. If I head over to my IDE, let me get this out of the way real quick. You can see here, I'll go ahead and interrupt that. You can see it's paused the board. I'll rerun the code, and it's up and running. And this is the code.py that's on there right now. So all the functions I would expect from a USB-C cable that has 5-volt power, that has data going in both directions, that's all working. So a little demo there to show you how that's still functional. Let me see what else. I'll go. Let me go back to a nice little picture here, and I'll take a look at some questions. But by the way, I forgot to mention, thank you for joining us over in the YouTube. Over on YouTube chat, we got Dave Odessa, Beatograph Avdalhagen, Tyrone Mix, Gordy G. Hello, thanks for popping by. The question from Gordy there that I noticed was, can you put the fixer on the far side of the monitor? Yes, you can. You will not power the monitor, however, I don't think. Let me see. I don't know if it'll negotiate its way through that. Well, that's very clever. I think you're right. I take that back. I think that will work. So let me go back to the down camera. So you can see here, nothing's asking for 5 volts. We're going to add these resistors to the chain. And you're absolutely right. It powers up. Very clever. Yeah, so as long as we've got a power and a ground line, that power supply said, I don't see what you want. Nothing's asked for anything. And then as soon as those have been added to the mix, it does power it up. So that should now work the same way, charge up my battery, charge up my little handheld gaming device there. So yes, excellent. Thank you. Great suggestion and great question. Let's see, what else? Does that conflict with negotiated power delivery? That's a good question. I don't think I have anything right here that will ask for anything but 5 volts, so I can't test that. It's a good question. I don't know if that's mentioned on the product page. Let me have a look, or if anyone in the chat knows the answer to that. I think the question is, if this CC fixer is in here asking for 5 volts, what happens if something else is asking for more? You probably don't want to do that, but I can't tell you without testing it myself how that would work. The other chat I wanted to say hi to, hey, hello Discord, there you are. So if you're somewhere like Facebook and you don't see a chat, head over to our Discord. That's at adafru.it/discord. Look for the live broadcast chat channel right over there. And no questions in there, but hello Bliss City DIY. Hi Liz, hey Thin Man, hey C Grover, hey Uniscu7, hey Todd Bot. This is not the live broadcast rat channel. I think you're in the wrong place. Beatograph of Delhaga says, do you have a HUSB 238 handy? Oh, okay. Yeah, that's a good. Yeah, let's try that. I like your thinking on that. Let's try that. So I'm gonna go grab another gizmo. It's all gizmos around here. Let's see. Okay, so this is something I had shown on another product demo, and this is one of our HUSB 238s that can be digitally controlled, so we can tell it what power to ask for from the supply. So let's try it first with a direct connection. Why are you not powering on? Huh. I don't know why the screen's not powering on. I see that it's lit there and it's getting the power. Ah, darn. Did I do something to you? Did I overwrite this firmware? That's my fear. Unless I've forgotten how this one works, maybe I need to. No, I don't think I'm feeding it from over here. No, this should be powering up here, unless it is. Yeah, darn. Sorry. No, that's bad demo. Can't. Let's just see. Does the resistor fixer fix it? I don't think that will. This should just be powering it on, and yeah, I think I've overwritten the firmware on here by accident, or something else is going on. Something got disconnected. Sorry about that. Yeah, I don't think I had a power on for this, so that should have just worked. Drat. I will say, I suspect that, and I will try this for real, but I suspect that having this here is going to say, hey, I want 5 volts. Normally, this is controlled by each device having a different resistor value pair that negotiates or asks for the voltage it wants, and so I think having this in there is going to set this to 5 volts. Probably you won't be able to ask for others once it's there. Let's see. Any other questions? Hello to QuinMan16 for jumping in there. Hey, some nice USB chat channel. Microcontroller with USB-C pass-through might be a neat idea for sure. Okay, well, sorry about the dud demo of the suggestion. I like the suggestion. I don't think I have another easy way to test that right now. So if anyone wants to experiment with that and let us know in the chat, that would be amazing. Otherwise, I think we'll wrap it up. So that right there is the QR code. If you want to head to that QR code, that URL, you will find yourself here. These are, let me refresh, should still be available. We got 73 of them in stock still. Price will go up in a few minutes after the show, so you'll want to throw some in the cart and get those, probably along with some other items. John Milton over in the YouTube chat says, if the fixer were put after an item that requests 5 volt, will it burn up the LEDs in the fixer? I cannot imagine that it will. Oh, sorry, an item is asking for more than 5 volts. Will it burn up the LEDs in the fixer? Again, I don't think I have a good way to test it. Actually, I am curious about one other thing I do want to try. Since I have two, since I have 2 of them here, we can try this. Let's try one other thing. Let's go to, yeah, we'll do fixer to meter to my possibly dud gizmo here. I may just have the wrong firmware on it. I was kind of just curious to see. Yeah, this is not powering on, and I don't know why. Did you get dropped? Yeah. Can we pull you apart? All right, let's keep going. Let's keep trying. I think I can just pop this off. Let's just see if it's something simple like something got disconnected. Connected. Oh, okay. Yeah. Okay, now I know what I did. This is still working just fine. I forgot that I'm not powering the feather through the... Yeah, we got two... Okay. I think we can get this working. Let's try it. So here is USB to power the feather. Feather is on. Is this upside down? Okay. All right. Now, let's do... In fact, I can put the meter in here, or we can just watch the screen. Okay, so now this is my USB-C, which, as you can see, our HUSB device does negotiate correctly for the voltage. That's its job. And I'm going to press the reset. Okay, so it's asking for 5 volts right now. And then I can ask for 9 and set it. Should be asking for 9. See, that's how it works. Okay, so now let's do the same thing, but I'm going to use the fixer. And the question here is, will there be an open flame in John Park's workshop here? Will it destroy the thing? Will it say, no, I can't possibly give you what you're asking for? That's too confusing to me. Let's see. Let's reset. Oh, even better, it doesn't want to start. That's interesting. So there may be, and this is just some simple code that I have running here, but it may be the case that it can't find any available. What I think is when this is starting, I'm checking for the available voltages, and it's only finding one. My code is kind of breaking on that. So I think the HUSB does not agree that this is a power delivery supply anymore because the USB fixer is in the way. They're asking only for 5 volts. So if I pull that out of there and reset, yeah, it should work again. Okay, so there's the answer to that. I don't think we can negotiate, and I don't have an output it's USB-C. I only have an output that's this DC power over here for this particular demo. So hopefully that's helpful in answering some of that. I think you're going to only use this in cases where you need the 5 volts and your gizmo doesn't. I wouldn't try to involve it when proper power delivery requirements of anything beyond the 5 volts are in play. Phew, okay. Hopefully that helped answer that, and I also remembered how my gizmo worked. Okay, I think that's going to do it. Let's wrap that up. So that right there is too many of me. Whoa. That right there is the product pick of the week this week. It is the USB Type-C CC resistor fixer. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week. Bye-bye.